Corporate Finance Practice Problem using Excel. Expected value, standard deviation, and coefficient of variation problem number 2. Get ready, it's time to take your chance with Corporate Finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet and would like to follow along, note that we're in the Practice tab as opposed to the Example tab. The Example tab, in essence, being an answer key. We have the information on the left-hand side. We're going to populate that into the blue area, mainly on the right-hand side. We're forecasting into the future. This is the second problem of a similar nature, so I'll do this a bit quicker this time. Same kind of scenario as the prior problem. We have the advertising campaign that we're imagining to happen. This is one of many types of scenarios where you might go through this type of thought process. Then we're going to group our possibilities together and see if we can come into a systematic kind of grouping for them, add probabilities to them so that we can get a statistical type of analysis, which could help us to move forward with a decision-making process. So we're going to imagine then the outcomes, possibly based on looking at prior outcomes, are going to be grouped into either low, average, high, very high, and then we're going to say that the outcome relation to that will be measured in units. So if the advertising campaign is low, possibly compared to prior advertising campaigns and projecting out into the future, we think we're going to get the 700 for that campaign. If it's average, then we're thinking we're going to get 800. Notice, of course, these are kind of averages, because if we look at prior campaigns, then we're looking at a range around there, right? So we're probably picking, the low ones on average, the average ones here, and then the high of the 1,000 and a very high or good campaign, 1,600. So the next thing we would do is calculate or figure out what we think the probabilities will be of those results happening. The probabilities having to add up to 100% here. So we think that the low is 30, average 30, high 30, and very high is 10%. So now we can look at that and try to figure out our expected value, which you could think about as kind of like the average value. So we'll say this is going to be the 700 units for the low times the 30% likelihood. We'll take the 800 times the 30% likelihood, the 1,000 times the 30% likelihood, and the 1,600 times the 30% or the 10% likelihood, and that's going to give us our expected value. Now, we can think of that about that as kind of like the average value. If we sum these up now, it equals the sum, and that's going to be the 910. So we can basically think, okay, the 910 looks about, we're going to say kind of like the average or expected value based on the assumptions that we're taking here. That's kind of like the average that we have. Now, oftentimes that might be a lot of kind of calculations that you might do in many scenarios, is to come up with that number and use it going forward. We could go further than that and do more statistical analysis for it. Oftentimes, when comparing multiple projects, we want to look at the variance or the variation, oftentimes looking at that coefficient of variation. So I want to calculate these, and we want to look at them and using our statistical tools, our further statistical tools. And it can be a little confusing because if you've worked with data sets, then they don't lay out mostly this way. You're usually looking at a data set, which is like just a series of numbers and outcomes and whatnot. So let's put this into our series of numbers and outcomes, calculate it that way, and then we'll do it the standard way for the corporate finance with this kind of data set and see how the similarities look, so we can apply our statistical kind of analysis and see what exactly we're doing with it. So let's just imagine there, if we put in 10 numbers and 30% came out to be the 700, 30, 800, 30, 1,000, 10 at the 1,006. Let's just add those numbers in here and pretend that of 10 results, we got the 700. I'm going to make 3 of them because it's 30%, 3 of 10. Then we're going to take the 800, which is going to be, once again, 3 of 10. Then we'll take the 1,000, which will take 3 of those, 3 of the 1,000. And then finally, the 1,600. I'm going to underline that. And so now we're mirroring this in 10 results. We're imagining 3 at the 7, 3 at the 8, 3 at the 1,000, and 1,600 at the 10%, at the 1,600, one of them. Summing that up, we're going to call this the total. I'll sum this up, equals the SUM. The SUM. So there we have that. And then the next thing, and notice we're basically doing this formula here, the population variance. So we're taking that each each unit we'll have here minus the mean squared divided by the population size or the number of items. So we'll take the mean or the average now. I'm going to put the mean all the way down. This is going to be equal to, I'm going to calculate it with the with the average function, mean or average, and then we'll just add these up, or not add them, or using the similar thing as the sum function, which is the series of numbers for those items, we get the average of the 9, 10. The average, of course, being the sum of these numbers divided by the amount of items, which are 10, which would be the 9,100 divided by 10, or the 910. Now I'm going to say this equals the item above it. Put my cursor on that and copy that all the way down, autofill that down. We'll put an underline. Well, let's keep it there. We don't need an underline. We're not going to total up those. And now let's subtract them out. So the value minus the mean. So we're doing this calculation for each data point, right? We're going to say this is the 700 minus the 910, the 700 minus the 910, the 800 minus the 910, the 800 minus the 910, the 800 minus the 910, the 1000 minus the 910, the 1000 minus the 910, the 1000 minus the 910, and the 1600 minus the 910. So now what we want to do is square them. That's going to be this part of the equation. That'll make these negative numbers positive. So we're going to say this will equal this number, shift 6 to the caret, in other words, 2, squaring it. Going to copy that down. Just going to autofill that on down. Autofill, double click on the bottom one, see if it looks like it should. It does. That's exactly what it should look like. And then we'll underline this item, and let's go ahead and sum these up then. So we'll sum this up equals the SUM, the sum of these items. That's going to be the 669,000. And then we'll pick up the population size. That's just going to be the count. There'll be 10 of them. I'm going to use this Excel function to count them, though. Equals the count, shift 9, and then selecting this range of data. It'll just pick up the ones with items in it, or 10 of them, underlining there, font group and underline, and that's going to give us the population variance. Population variance then being equal to the 669 divided by 10. That's basically this calculation, n being the population there. So now that still takes into consideration those squared items. So then we often want the standard deviation. Let's go ahead and pick it up from here, standard deviation. And for that, we'll take the square root to kind of get rid of the squared kind of component, equals the item above it, not the item above it, equals the SQ, square root, SQRT is the function for it, the 66,900. And so then let's add some decimals, number group, adding a couple decimals, 258.65. And then we're going to pick up the mean or the average, which I could do it this way again. Let's pick up the cell over here. I'll calculate it again with the average function. That's going to be equals average of this data set. That gives us the 910. Let's underline that, font group and underline, and then we have the coefficient of variation here. And that's going to be equal to the 258.65 divided by the mean or average. We could percentify it or simply add a few decimals. I'll add a few decimals here. Okay, so then we can do the same thing in our data set to the side. Oftentimes you'll see the data set over here if you just calculate this in Excel. So we can calculate the average over here, which would be the mean. And so picking up the mean of these numbers, you can have the standard deviation, the standard ST. Whoop, I need an equal. I was like, why isn't anything showing up there, popping in there? And I'm going to take from the population rather than the sample. That's what we're going to be using. Standard deviation of these items. So there's the standard deviation matching up. The variance would be equal to VAR. And we'll take it for the population again. Variance for the population, picking up these numbers. And there is that. And then once again, once we have those, we can then take the standard deviation and divide it by the mean to get to the coefficient of variation, the 0.2842 about. I'm going to add one more decimal there to match it up. Okay, so that's one way we can see it, that we might be more familiar with these calculations. Oftentimes we'll be focusing here if we're comparing multiple different scenarios. We'll see that in the future, but I just want to practice these calculations. Now let's do it the way we would do it normally here. If we didn't have the data set, we'll do it kind of like the corporate finance kind of way, where we're going to say, all right, now we'll pick up the same data set, the 700, and pull that down. I'm not going to break it out into like a series of 10, but I'm going to use the percentage or weights, and you'll see how those come into play here. The expected value is going to be like the average, but we're going to have, that's going to be like the expected value that we calculated first here. You'll note that's the mean or average we calculated when we did our kind of data set over here. And then we'll copy that down, the 9, 10, and then we'll subtract them out, kind of mirroring this process. So now we'll subtract them out. This is going to be the 700 minus the 900. Let's copy that down. Autofill. There we have that. And now we'll square it, similar fashion as we did over here. So this is going to be equal this item to the shift 6 or caret 2, squaring it. Then we'll take that and copy it down, copying it down. So there we have it. And then we're going to apply our probabilities now. So now once we squared it, this is the thing that's, different than our data set here. We're going to take the probabilities, which are going to be the 30, 30, 30, 10. 30, 30, 30, 10. And then let's select these three and go to the numbers, make it a percent. Grab that 30, drag it on down. 30, 30, 30, 10. And then we're going to say this is going to be equal to the 44.1 times the 30. And let's autofill that and drag it down. And that'll multiply them all across. So there we have that. Let's total it up. Total is going to then be equal to the sum of these items. And that's going to give us our 66.9. Let's actually call that, the population variance. Underline here, font group and underline. And then we'll take the square root, which I'm going to call the standard deviation. The standard D equals, and that's going to be equal to the square root of this number above it. Enter, add a couple decimals, numbers, couple decimals. So that matches up here. And then we'll look at the expected value. So the expected value, let's pick that up over here, which we calculated. The expected value is going to be equal to, and that's basically the average, right? The average or the mean. A lot of different names for that one. It's an important number. We know it by many different names. It's been known by many names. And we're going to say this is the coefficient of variation, which is going to be equal to the 258 divided by the expected value, mean, average. And something went wrong. Hold on a second. This divided by this, adding a couple decimals. There we have it. So there's the coefficient variance. So again, in practice, you might then, be really looking for this if you're doing one kind of calculation, looking at your expected value of the 910. And then again, if you're comparing different projects, oftentimes we're going to get down here to the coefficient of variation, which could give us some idea about the spread of the data and give us some more indications about them depending on the different data sets and what we're trying to get from them. We'll do some comparisons in the future, but again, we just want to get used to the statistical kind of analysis and a couple different scenarios on where you could apply that type of analysis.